Hi friends, welcome back to our YouTube channel. Today we have to discuss about NPTEL problem solving through programming in C week 8 programming assignment. The due date for week 8 programming assignment is 22/9/2022. First program, write a C program to find HCF of given four numbers using recursive function. So this is the required code of this program. Int HCF int x comma int y within the body of this function while x not equal to y. If this condition is true, then the control goes to the body of the while loop. Here, if x greater than y, we can call the recursive function. So return HCF x minus y comma y. If this condition is false, then go to the else block. Again, we can return the recursive function HCF x comma y minus x. Okay. If this condition is false at the while loop, the control goes to the next statement after the while loop, return x. Okay, x contains the HCF of four numbers. Now we have to save this program and we have to click on the compile and run button. So compilation passed, public test cases 2 by 2 passed. So test case 1, so input 4 numbers are 67, 89, 45, 41. Expected output is HCF is 1, actual output is HCF is 1. Both actual output and expected output are equal, then we can say that status is passed. Then test case 2, the four numbers are 50, 455, 60, 200. Expected output is HCF is 5 and actual output is HCF is also 5. Both actual output and expected output are equal. Then we can say that status is passed. So then we have to submit this code. So see this one. So test case 1 passed, test case 2 is also passed. Then we can go to the second program. Write a C program to print binary equivalent of an integer using recursion. Suppose we are taking an integer, then how to find out the binary equivalent? We can divide that number with 2 until the quotient value is 0. Once we are getting the quotient value is 0, we can write the remainders from bottom to top. So that is the simple logic for print the binary equivalent of an integer using recursion. So this is the function int binary conversion int num. This num contains the integer to find the binary equivalent for that integer. If num equal to 0, if the given number integer value is 0, print the return 0, else return num modulus operator 2 plus 10 into binary conversion num by 2. So this is the simple code for finding out the binary equivalent of an integer using a recursion. Now we have to click on save as draft and click on compile and run button. So see this one, compilation passed, public test cases 2 by 2 is also passed. Test case 1, input is 10. The binary equivalent of 10 is 1010. Actual output is, the binary equivalent of 10 is 1010. Both actual output and expected output both are equal. Then we can say that status is passed. Next one, input is 257 in test case 2. Expected output is, the binary equivalent of 257 is 1701. Here actual output is, the binary equivalent of 257 is 1701. So both actual output and expected output are equal, then we can say that status is passed. So then we have to submit that program. So now test case 1 is passed and test case 2 is also passed. Then we can go for week 3 program. Write a program to calculate the sum of a given series 1 plus 1 by 2 square plus 1 by 3 cube plus 1 by 4 power 4 up to 1 by n power n till nth term. So this is the simple logic. Double series sum, we are passing n value. So within the body of the function, I can be declared as integer. Double sums is equal to 0.0. So variable sums can be initialized with 0 and it can be declared with a double data type. So we can declare another variable ser. For I equal to 1, I less than or equal to n plus plus I. So within the body of the for loop, ser is equal to 1 by power of I comma I. Sums is equal to sums plus ser. So once this condition is failed, the control goes to the next statement after the for loop. So return sums. So this is the simple logic to find out the series of sum of the given series. Save as draft and click on compile and run button. So see this one, compilation passed, public test cases one by one passed. Public test case 1, input value is 3, expected output is the sum of the series is 1.287037 and the actual output is the sum of the series is 1.287037. Actual output is equal to the expected output. So then we can say that status is passed and click on the submit button. So series 1 test case 1 passed, test case 2 is also passed. Now we can go for the fourth program. Write a program to express a given integer as a sum of two prime numbers. For example, if the number is 10, the result will be 10 is equal to 3 plus 7, where 3 is prime number, 7 is also prime number. 10 is equal to 5 plus 5. 5 is also prime number. 5 is also prime number. So this is the simple program. So the logic is here. Int I comma flag is equal to 0. For I is equal to 2 semicolon I less than or equal to n by 2 semicolon plus plus I. Here we have to check the given I value is a prime or not. If the given I value is a prime, check of prime of I equal to 1. We have to check whether the given I value is prime or not. If it is a prime, check prime of n minus I equal to 1. This condition is also true, then printf percentage %d is equal to percentage %d plus percentage %d. This is the prime number. This prime number can be formed as a sum of the two prime numbers. So n comma I comma n minus 1. So flag equal to 1. Next one. If flag equal to 0, printf percentage %d, the given number cannot be expressed as a sum of the two prime numbers. Return 0. Next one. Int check prime. This logic is, we are also know that this logic is used for checking whether the given number is prime or not. Once the given number is a prime, then that number can be formed as a sum of the two prime numbers. This is the logic. This logic is used for checking the given number is prime or not. Once it is prime, then that can be expressed as a sum of the two prime numbers. So now save as draft and click on the compile and run button. So see this one, compilation passed, public test cases 2 by 2 is also passed. In the test case 1, input value given as a 7. So expected output is 7 is equal to 2 plus 5. 2 is prime number, 5 is prime number. So 7 is also prime number. That prime number can be formed as a sum of two prime numbers. Actual output is 7 is equal to 2 plus 5. Both actual output and expected output are equal, then status is passed. In the second test case, input is 11. 11 cannot be expressed as a sum of the two prime numbers. That is the expected output. Actual output is 11 cannot be expressed as a sum of the two prime numbers. Both actual output and expected output are equal, then we can say that status is passed. So after that we have to submit the solution. So now test case 1 is passed, test case 2 is also passed. So these are the 4 programs in week 8 programming assignment solutions. These solutions are written in comment box. If anybody wants, please copy from the comment box. I hope all of you understanding this video. If you like this video, click on the like button and share this video to your friends and classmates. If you like this video, please subscribe my YouTube channel, Divvela Srinivasarao. To get the more updates from my YouTube channel, click on the bell icon after subscribing my YouTube channel, Divvela Srinivasarao. Thank you one and all for watching this video.